All right, welcome everybody. Today we're going to talk about section 5.4, and this is all about solving radical equations. The truth is, you already did the exact opposite of this procedure back in section 5.1 when you were solving using nth roots. So we're going to go ahead and do a couple of review problems with that technique before we go ahead and do the opposite here in 5.4. So for something like number 1, 4x to the fifth equals 128. If you were solving this a couple of days ago, hopefully you would remember that you would start by dividing by 4. That would give you x to the fifth would be equal to 32. Then, because you have something to the fifth power, the way that you would get rid of something to the fifth power is by taking the fifth root of both sides. If you take the fifth root of x to the fifth, you just get x. The fifth root of 32, you could either use your cheat sheet or use your calculator. You're going to go ahead and get an answer of 2. Because you're taking an odd root, there's going to be just one answer, so 2 is your final solution. Remember, it would be perfectly fine for these to be decimals as well, but I made them nice integer answers just to keep things a little bit cleaner. Here in number 2, notice that you start by having an entire quantity raised to the power of 4. You're not allowed to do anything with that 2 until you eliminate the fourth power. So the way that you would eliminate that fourth power is by taking the fourth root of both sides. On the left side, taking the fourth root of something to the fourth power would cancel to just be x minus 2. Over on the right, the fourth root of 81, either using your cheat sheet or your calculator, would be equal to 3. And then because of the fact that you're taking an even root of a positive number, you would have to have plus or minus 3. Remember that you're not solving for x minus 2, you're solving for x. So in order to get the x by itself, you would have to add the 2, plus or minus in the middle, and then 3 in the back. Technically, that is the right answer, but you could go farther by doing 2 plus 3, which is equal to 5, and 2 minus 3, which is equal to negative 1. So either of those would be acceptable, and these are your answers here in number 2. Finally, something like number 3, you're going to go ahead and start by adding the 36. Because the 36 is not underneath of the cubic, you can go ahead and add it to the right-hand side right from the start. So x to the third equals negative 64. In order to get rid of that cube, you're going to go ahead and take the cube root of both sides. On the left, the cube and the cube root cancel to be x. On the right, the cube root of a negative is a negative, and the cube root of 64 is 4, which again, either use your cheat sheet or use your calculator, and you're going to go ahead and get one single answer of negative 4. So again, that's a review of some of the techniques that you did back in section 5.1. And now we're going to go ahead and actually do the exact opposite, which is to solve radical equations. So when we're solving radical equations, instead of starting with a power that's an integer, a square, a cube, or a fourth, you're going to start with a power that's a fractional exponent, a half, a third, or a fourth, and you're going to have to undo that power by either raising both sides to the squared, the cubed, the fourth, etc. So again, these are solving radical equations. You'll know that you have a radical equation where you have variables in the radicand, which again means underneath the radical symbol. Here's an example. 2 times the square root of x plus 1 is equal to 4. You probably have solved these types of equations at some point in your mathematical career, but perhaps not lately. So we're going to go ahead and review that here in 5.4. Generally speaking, these are the steps that you're going to follow whenever you are trying to solve a radical equation. So step 1, isolate the radical on one side of the equation if necessary. Remember, a radical can be a square root or a cube root or a fourth root. Doesn't matter what the index is, you're going to go ahead and start by isolating it. Then step 2, raise each side to the same exponent to eliminate the radical, and you're either going to get a linear, a quadratic, or some other polynomial equation. Step 3, solve the resulting equation using techniques you've learned in the past, and then check your solution. So check your solution is kind of the important thing to point out here. The truth is, it doesn't take very long to check all of them, so you might want to get in that habit, especially on a test or quiz. Again, it doesn't take very long to actually check, but then there are a handful of problems where you have to check the solution, so we're going to point those out as well. Where you have to check your answer is if there are variables on both sides of the equation. We're not going to see those until a couple of examples in, but that is when it is required for you to check your solution, when there are variables on both sides. But otherwise, it's just kind of good practice to check if you have a free minute. And then just another little reminder before we go ahead and get started, if you see the square root of x, please make sure you remember that technically that is x to the 1/2 power. Whereas if you see the cube root of x, remember that that is x to the 1/3 power. The fourth root of x is x to the 1/4 power, and then so on and so forth down the line. You want to make sure that when you see the left side, you think of it as the right side. In fact, you might want to rewrite it so that you don't forget, because in order to eliminate those fractions, you're going to have to raise it to the integer, which again is the opposite of what you did back in section 5.1. So let's go ahead and dive in and actually do a bunch actually. We're going to go ahead and solve each equation for x, and then again, check your solutions as needed. So I will point out the ones that you're required to check, but along the way, it never hurts to check if you have a free moment. So let's take a look here at number 1. If you kind of refer to the steps above, the first step was that you're trying to isolate the radical. So in order to isolate the radical, I'm going to go ahead and divide both sides by 2, which gives me the square root of x plus 2 is equal to 4. Remember, the square root is equal to the 1/2 power. So in order for you to get rid of that radical, which means you can release that x plus 2, you're going to have to go ahead and take both sides and square both sides. On the left side, if you square a square root, that cancels to be x plus 2. On the right side, if you square 4, you get 16. Finally, to solve for x, go ahead and subtract 2, and that's going to give you an equal of x equals positive 14. Again, if you have a quick moment, it doesn't hurt to check. If you wanted to check, you're going to go ahead and take that 14, plug it back in for x, and make sure it gives you a true statement. So if you do 14 plus 2, you get 16. The square root of 16 is 4. 4 times 2 is 8. So it certainly works. And again, takes but a few seconds to check. So I think it's a good habit to try to get into. Similarly here in number 2, so you are going to go ahead and try to solve for x. First thing you're going to do is realize that this floating negative 2 out back, you're going to go ahead and add that 2 to both sides. That's going to give you the cube root of 2x minus 5 is equal to 5. When you see this cube root, that technically means that it's being a 1/3 power. So to get rid of a 1/3 power, you're going to raise both sides to the cube. On the left side, that's going to cancel out the cube root. That's kind of the whole point. On the right side, 5 cubed, that's equal to 125. And now you're left with just a normal linear equation. So you're going to go ahead and add 5 to the right, which is 130. Ultimately, divide by 2, and x is going to equal 65. Unlike the problems you did back in section 5.1, you don't have to worry about the plus or minus here. Again, you do have to worry about checking your solutions, but not yet. But again, you don't have to worry about the plus or minus other than when you're checking. And then here in number 3, so in number 3, again, anything that is outside of the radical is fair game. So you're going to go ahead and add the 9 to both sides. That is going to give you the cube root of x is equal to 3. A cube root is a 1/3 power. So the way that you get rid of a 1/3 power is by cubing both sides. That's going to give you an x on the left. That's going to give you a 3 cubed on the right. So you're going to go ahead and get an answer of x equals 27. And again, if you're wondering how I'm able to do these calculations so quickly, I mean, I'm familiar with the power, so I can do them without a calculator or without my cheat sheet, but you're certainly welcome to use one or both as needed. Let's go ahead and do a couple more. Pretty similar here in number 2, nothing too crazy, but let's go ahead and take a look. So here in number 4, what you want to notice is that there is a negative on both sides. You don't want to square or cube or do anything until you have tried to isolate the radical on the left. And isolating the radical means getting rid of anything other than just the radical, which includes that negative. So the good news here is because both sides have a negative, they actually cancel out. And you're left with the square root of x plus 1 is equal to 8. How do you get rid of a square root? Well, you're going to go ahead and square both sides. So on the left, they cancel. On the right, 8 squared is 64. To get the x all by itself, go ahead and subtract the 1, and 63 would be your answer. Here in number 5, we're going to go ahead and again, always start with things outside of the radical, if at all possible. So we're going to go ahead and subtract 1 from both sides. That's going to give us the cube root of 2x minus 9 would be equal to 7. A cube root is a 1/3 power, so the way you get rid of that is by cubing both sides. So on the left, you're going to get 2x minus 9. On the right, 7 times 7 times 7. Again, cheat sheet or calculator will be 743. Add the 9 to both sides, and you're going to get that 2x is equal to 352. Your final answer, divide by 2, and you're going to get 176. Now, again, I have tried to pick values that turn out to be nice and integers, but please don't be surprised if you get big numbers, small numbers, decimal answers even. So it's not a given that they have to be nice numbers, so no worries if they aren't. Here in number 6, this is our first fourth root. And again, notice that the entirety of the left-hand side is underneath that fourth, which means that 25 is not able to be dealt with, at least not yet. A fourth root, that is equivalent to a 1/4 power. So the only way to get rid of that is by raising both sides to the power of 4. On the left, it's going to go ahead and cancel. On the right, 2 to the 4th is 16. And then you're going to go ahead and subtract. So 16 minus 25, that's going to go ahead and give you an answer of -9. It is going to get a bit more complicated in just a second. So very important that you make sure you're kind of mastering these easier problems. And if you have any trouble at all, feel free to ask your teacher a question when they pause it for you. Let's go ahead and take a look here at number 7. So in number 7, really nothing too crazy other than the fact that we have to be extra cautious for the things that are outside of the radical versus the things that are inside the radical. Again, you're not allowed to deal with anything in the green until you've gotten rid of that square root. In terms of the 2 and the 5, if you're unwrapping that green piece, you have to start by undoing your order of operations. So you're going to start by subtracting 5. That's going to go ahead and give you an 8. Then you're going to divide both sides by 2. That's going to give you a 4. Because you have a square root, the way you would undo it is by squaring both sides. So 2x is what you're going to get on the left, and then 4 squared is 16 on the right. Divide by 2, you're going to go ahead and get a final answer of x equals 8. And again, nothing really crazy about that one other than the fact that you have a lot going on. So again, just pay close attention, the inside versus the outside. Make sure you're dealing with the appropriate question in the correct order. And now for these last two, hopefully you can realize these look a little bit different. They look a little bit harder. And the main reason why is because of the fact that in these problems, number 8 and number 9, there are variables on both sides. So if there are variables on both sides, you have to check your answers. You don't have to check till the very last step. It doesn't take long at all. And again, the reason why you are required to check your answers here is because of the fact that you have variables on both sides. If you don't have variables on both sides, you don't really have to worry about checking your answers. But again, it's pretty quick to do, so it's a pretty good practice to get into if possible. Number 8 is actually kind of the dream, though. As far as variables on both sides go, this is kind of the best case scenario because not only are there variables on both sides, but there's actually square roots on both sides. So the goal, remember, is to isolate the radical. And in this case, you have a radical on the left and you have a radical on the right. So that's actually good news. The way that you can go ahead and get rid of both of those square roots is by actually squaring both sides. So on the left, if you square a square root, you're just left with 4x plus 1. On the right, if you square it, you're going to get just x plus 10. And now you're going to go ahead and just solve this equation. So I'm going to put all my x's on the left side. That's going to give me 3 of them. I'm going to put my constants on the right side. That's going to be equal to 9. I'm going to go ahead and divide by 3, which is going to give me, I won't say the answer, I'll say a potential answer of x equals 3. In order for me to know for sure that it is the answer, I'm going to have to go ahead and check it. Where do you check it? You check it in the original. What are you checking for? You're checking that it does, in fact, make the two sides equal. So on the left side, if you plug in 3, you're going to get the square root of 12 plus 1. If you check the right side, you're going to get the square root of 3 plus 10. Positive 12 plus positive 1 is positive 13. 3 plus 10 is positive 13, which means that it's a go. That means that x equals 3 is, in fact, a solution. Again, doesn't take long to check, but you should do it. And the reason why you're doing it is because you have variables on both sides. That was the easy version of what happens if you have variables on both sides. And now here in number 9 is the harder version. So notice here you only have one single radical on the right-hand side. Your first step was supposed to be to isolate the radical, which is done, but now you need to get rid of the radical. So in order to get rid of the radical, you're going to have to go ahead and square both sides. But here's where you want to be careful. On the left-hand side, when you square x minus 6, you're getting a FOIL, x minus 6 times x minus 6. That's one of the most common mistakes that people make is they forget to do the FOIL. So if you don't want to forget, go ahead and write yourself out 2 copies. Over on the right, if you square a square root, you're going to just go ahead and get 3x. So over on the left, again, you're going to go ahead and use the magic word, which is to FOIL. So first, outers, inners, last. Hopefully you notice that what we have now is a quadratic. And if we have quadratics, think back to all of chapter 2 and 3, we like those quadratics to be equal to what? Equal to 0. So we want to go ahead and put everything on one side. So I'm going to leave the x squared where it is. I'm going to combine all the x's to be negative 12 of them. I'm going to go ahead and then plus 36 equals 3x. Again, you want to put all of your x's on the same side. So I'm going to subtract 3x. That's going to give me x squared minus 15x plus 36 equals 0. If we're nice, it's going to factor. If we're not nice, you're going to use the quadratic formula. But luckily for us, you're looking for 2 factors of positive 36 that add up to be negative 15. I think that will work if you choose x minus 3 and x minus 12. Again, negative 3 times negative 12 equals positive 36, and negative 3 plus negative 12 is negative 15. That gives you 2, and again, not answers, but potential answers of 3 and 12. How do you know for sure if they're answers? You have to actually go ahead and check them. Where are you checking them? In the original. What are you checking them for? You're checking to make sure that they give you 2 sides that are equal. So you're going to go ahead and start by checking positive 3. So if you check positive 3 on the left side, you're going to get 3 minus 6 equals the square root of 3 times 3, which is 9. 3 minus 6 is negative 3. The square root of 9 is 3. So that actually does not work. You are not going to get a true statement, which means 3 is not an answer. Just so you know, that is what we call in the math world an extraneous solution. The extraneous means it's an extra solution. So just if you hear that word, it means an answer that does not work. You're going to go ahead and cross it out and fully on eliminate it. Then we're going to go ahead and we're going to check 12. So again, going back to the original, you're going to do 12 minus 6, and then you're going to do the square root of 3 times 12 is 36. So 12 minus 6 is 6. The square root of 36 is 6. That's a winner, which means that x equals 12 is your only answer. So again, these checks have to happen when you have variables on both sides. And pretty much whenever you have a FOIL, you know that if you're squaring something that was not squared before, that's usually a good indication that you might end up with an extraneous solution. So now that we have finished the straightforward problems, let's just go ahead and take a look at a couple of word problems here. Again, nothing really more difficult about the solution here. You just have to go ahead and be able to solve it in the context of a problem. So biologists have discovered that the shoulder height in centimeters of a male Asian elephant can be given by the following. And again, we would have to give you equations like this. We would not expect you to come up with that on your own. Where T is the age in years of the elephant. Determine the age of an elephant with a shoulder height of 250 centimeters. So given the equation and given certain pieces of information, all you have to do now is be able to solve. So you are trying to determine the age. If you're trying to determine the age, that means you're going to solve for T. If you're going to do that, you have to know the height, and it tells us that the height is 250 centimeters. So you're going to go ahead and replace the H with a 250. 62.5 times the cube root of T, and then plus 75.8. You're going to go ahead and solve this exactly the same way that we did the previous problems. The only difference now is you're going to have a little bit of decimal action. So you're going to start by subtracting 75.8 from both sides. Obviously, you'd want to have a calculator for that. So 250 minus 75.8 is 174.2. Then you want to make sure you isolate that radical. So you're going to go ahead and divide both sides by 62.5. That's going to give you 2.8 is equal to the cube root of t. Remember, the cube root is the same as a 1/3 power. So the way that you would get rid of that is by cubing both sides. If you cube the right-hand side, cubing a cube root, that's going to go ahead and cancel. If you do 2.8 to the third, you would get 21.95. And again, because you're talking about years, you can probably go ahead and say that that rounds to 22 years. When it comes to rounding, just make sure that you answer the question using any directions that it says. In this case, it doesn't say, but if we're talking about age, it kind of makes sense to round to the nearest year. So a elephant that has a shoulder height of 250 centimeters is approximately 22 years old. So learn something new every day. Keep in mind, you could also work the other way, whereas if I told you the age of an elephant, you could approximate its height or shoulder height. And then our final problem here. So here in our final problem, there is something called the Beaufort wind scale, and it's basically used to measure wind speed. The Beaufort number B can range from 0 to 12, and it's modeled by the following equation. So B equals 1.69 times the square root of S plus 4.25 minus 3.55, where S is the wind speed in miles per hour. So again, take a look at the table here just so you can be aware. If you're talking about a calm wind, that would have a Beaufort number of 0. Then as you get progressively windier from a gentle breeze to a strong breeze all the way up to a hurricane, you can see that the Beaufort number is increasing. They ask you in part A, what is the wind speed for B equals 0 and for B equals 3? So again, in this case, because they're giving you specific values of B, you can go ahead and calculate the wind speeds. So we're going to plug in 0, and then separately, we're going to plug in 3. So let's go ahead. This again is part A. We're going to go ahead and start by plugging in 0. So if I plug in 0 equals 1.69 times the square root of S plus 4.25 minus 3.55. You're going to go ahead and start by adding 3.55 to the left. Then you're going to divide both sides by 1.69. That's going to give you approximately 2.1. Once you get down to here, you're going to go ahead and get rid of that square root by indeed squaring both sides. If you square 2.1, you're going to get 4.41 is equal to S plus 4.25. If you go ahead and subtract 4.25, you're going to go ahead and get a wind speed of 0.16, and the unit is miles per hour. So again, that is really not very windy at all, which is why it has such a low Beaufort number of 0. That means it's a pretty nice day out. Then they say, okay, go ahead and do the same process, but this time for B equals 3. So if you're going to go ahead and do this for B equals 3, you're just going to repeat the process with a 3. So 1.69. Again, we would have to give you these equations because there would be no way for you to figure them out. So you're going to go ahead and add 3.55 to both sides. Then divide by 1.69. Then you're going to go ahead and square both sides. Let's double check my work here. Hang on. Okay, when you go ahead and raise both sides to the squared power, on the left, you get approximately 15. On the right, S plus 425. And then if you go ahead and subtract 4.25, you're going to get that the wind speed is approximately 10.75 miles per hour. Obviously, that's much windier, which is why it has a higher Beaufort number. So the last thing that they asked you here in part B is write an inequality that describes the range of wind speeds based on the model. So in order to do that, we would have to find the calmest wind and then also the hurricane wind. So we actually already did the first one. We found that the calm was 0.16. Then we actually did it for C as well, or for 3, and we found that that was 10.75. And then to do it for the other numbers, it would actually be the same exact procedure, which I kind of think we've got that down. So just to save you a step, turns out that in a hurricane, the wind speed is 80.41 miles per hour. So for question B, when they say to write an inequality that describes the range of wind speeds, you're going to go ahead and use a variable. In this case, the variable is S because you're talking about wind speeds. What's the lowest wind speed that can happen? It's 0.16. What's the highest wind speed that can happen? It's 80.41. So when they ask you for an inequality, here is what they're looking for. Again, it's a compound inequality. Put the S in the middle, put the lower value on the left, put the larger value on the right. And again, just to clarify, this 80.41, to find it, we would do the exact same process we already did twice. So I just saved you a step by telling you what it was equal to. So hopefully that's enough for you to go ahead and try tonight's homework. So thanks very much for tuning in, guys, and we will catch you next time.